So in this second part, I'm going to describe to you what the basal metabolic or the resting metabolic rate is. So first of all, it's important to understand a little bit about how it's measured. So a basal metabolic rate is the true minimum amount of energy your body has to generate to keep you alive. So to measure that, you have to be at rest, but not asleep, and you can't have done any prior activity or taken any sort of stimulant that would cause your metabolism to change. So it's kind of difficult to measure because you have to control a lot of variables. More often what we actually have is a resting metabolic rate, which is sort of, if you don't have a lot of time and you can't control things as tightly, you would ask somebody to sit calmly for 5 or 10 minutes, and then you would measure their metabolism with open circuit spirometry. You're going to measure their heart rate with a heart rate monitor, and you get an approximation of what their true basal metabolic rate is. Now, what does it take to have that minimum amount of energy? Well, throughout the day, have a look here, starting at 000, so midnight, 7 a.m., noon, 6 p.m., or 1800 hours, then 24 hours, so again midnight, a full day, what we see is that we're usually operating at close to that basal rate. Now when we get up in the morning, we might move around a bit and our activity increases, and we might eat a meal. And if we eat a meal, okay, we'll see that that takes some energy as well to digest the food. So after a little bit of activity throughout the morning, we're sitting in a chair again. Okay, maybe at lunch hour we get up, we go for a little walk, come back, okay, have another meal. Okay, another desk job in the afternoon or studying all afternoon. Close to dinner time, we go and we do a workout, and the workout is big, it would look like that. And after the workout, our oxygen consumption or our metabolism is a bit higher, okay? And then it kind of declines over the evening until we're asleep again. Now, one more meal, 3 meals a day. Okay. Our exercise is in blue. Okay, and our resting metabolic rate is all of this energy that we consume regardless of what we're doing. So we're never at zero. And what we find is that if we put that on like a pie chart, if this was the total energy in a day, we'd find that most of it was our basal metabolic rate. Basal metabolic rate. Okay, some of it, decent portion of it, up to 20%, that's a bit generous, would be exercise. Okay, so this is the energy to do work. And lastly, a small amount is always going to involve digesting our foods. And we call that the thermic effect of feeding. So why is all that important? Again, during exercise, there's a small portion down here that's not attributable to work. So during that exercise session, we do not want to include this when we're calculating net efficiency. What we want to know is, out of this energy, what percentage of that was actually used to do work. So, in order to estimate this, there's a quick, sort of easy method called a MET. And a MET is one metabolic equivalent. Now, because it's an estimate, we're making an assumption. And that assumption is this, and you must memorize this number, that 1 MET is equal to 3.5 milliliters per kilogram body mass per minute of oxygen consumption. So what we're saying is that at rest, generally, each person is going to exist at 3.5, or exist with 3.5 mils per kg per minute of oxygen consumption. So this is relative to body mass. If you weighed 85 kilograms, then 3.5 mils per kg per minute times 85 kilograms, so that cancels, okay? Convert from milliliters into liters, so 1 liter equals 1,000 mils, so the milliliters cancel. And we're left with liters, is going to equal to about 0.300 liters per minute of oxygen consumption. So, the generic term for everybody is relative to body mass. If you know somebody's body mass, you could calculate their absolute oxygen consumption. Now, another interesting thing you can do with a MET is that it relates to 1 kcal per kilogram body mass per hour. So, if you know somebody's body mass, you can estimate how many calories they burn throughout an entire day. So how do you do that? Well, if the person was at 1 MET throughout the whole day, so I'm going to return to my graph here, assume they did no activity, they just existed, kept their body functioning, and that they weighed 85 kilograms, you could say 1 MET, which is a kcal per kilogram body mass per hour, times 85 kilograms, which is their body mass, times all the hours in a day, 24 hours, and hours would cancel, and we'd be left with an estimation of 2,040 kcals per day. So sometimes people are interested in knowing basal metabolic rate in order to calculate net efficiency and in order to figure out how many calories you have to consume every day, not including those that you burn during exercise or during feeding. So, the next part, we're going to take an example of actual measurements of resting metabolic rate, and then we're going to try to compare ergometry during two different forms of ergometry in terms of how efficient they are.